That was the other thing somebody did on New Year's Eve. It was like 10:40 and he just started counting down from 10. People started losing their mind. Okay, today we're going to go backwards. Like I said, we're going to talk about some methods to prove that something's a parallelogram. It's pretty easy because we're just taking the theorems that we already know and using their converses. So the theorems that we already know say something like if ABCD is a parallelogram, then what? That's the way you know about a parallelogram. Then
the opposite sides are parallel.
good, the opposite sides are parallel.
Two? What? Well, I'm tired.
I understand. We're all tired. Suck it up, princess.
What was the question?
If ABCD is a parallelogram, then
A, B, and C, D are parallel?
she said that already. She said opposite sides are parallel.
Alright. The opposite angles are parallel?
Beautiful. Opposite angles are what?
Or congruent.
Congruent, thank you. Number 3.
Diagonals like bisect each other.
Beautiful. Number 4.
Adjacent angles equal 180.
Beautiful. Fancy name for that is?
Supplement.
Thank you. Yeah, good. Number 5. We missed a big one. Opposite sides are parallel, opposite angles are congruent, diagonals bisect each other, adjacent angles are supplementary, and? Don't hurt yourself, it's okay.
Congruent.
What's congruent?
Opposite sides. Are congruent.
Good, opposite sides are congruent. Anything else? Michelle?
All angles add up to 360.
Good, because it's a quadrilateral. But that's not specific to just parallelograms, right? All quadrilaterals?
Oh, yeah.
Okay, but it's still true. Anything else? Okay, so all we're going to do today is take those and switch them. By switching them, I mean we take the converse. So we're going to say, if a quadrilateral has opposite sides parallel, then it's a parallelogram. It looks something like this. And we've got a whole bunch of them. There's one new one here that wasn't a converse of the others. If you want to write all these down, that's fine. You already have them in your notes when we talked about parallelograms. But again, if you want to write. If you want to wait till later, the slideshow will be up. You can copy them down later, or you can just use them from the ones you already know. Okay, so if the opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. If the opposite angles are congruent, then it's a parallelogram. Number 3, if an angle is supplementary to both of its consecutive angles. So you can't just have 2 angles next to each other being supplementary. You have to start with an angle, and its 2 angles next to it have to be supplementary to it. Then it's a parallelogram. Number 4, the diagonals bisect each other. It's a parallelogram. What's special about the point where the 2 diagonals meet? Cricket.
Can you repeat the question?
Sure. What's special about the point where the 2 diagonals meet?
Is it the middle of the parallelogram?
Also known as?
Is it the circumcenter?
No. Those are only for triangles. For those of you that are visual learners, what's special about that point?
Is it a midpoint
Of?
of the diagonals?
Good. It's the midpoint of both diagonals. So one of the ways you can check this is calculate the midpoint of one diagonal, figure out where it is, calculate the midpoint of the other diagonal, make sure it's the same point. If it's not the same point, then they don't bisect each other. So it's not just a matter of showing, well, that's congruent to that and that's congruent to that. You can do it in some other sneaky ways. Okay. And then here's the new one. This is the one you definitely want to write down, because we haven't talked about this. This isn't a converse. If one pair of sides are both congruent and parallel, it has to be a parallelogram. if one pair of opposite sides are congruent and parallel, then it's a parallelogram. Okay, good? Let's see this in motion then. This is probably the slide you're going to go to when you want to get all this stuff written down, but here's all of them summarized on one slide. And we want to look at this guy. Okay, so I have 4 coordinates on a coordinate plane, and I want to see whether or not that's a parallelogram. So graphing it, well, yeah, that looks pretty close to being a parallelogram, but that obviously is not enough to guarantee that it is in fact a parallelogram. There's a couple different ways we can do this. We'll start with the color red to do the first one. What method, Mary, do you want to try first? Distance, beautiful. Okay, get out your calculators, please. Mary, find the distance from B to C. Morgan, can you find the distance from A to D? Michael, find the distance from B to A. And Emmett, find the distance from C to D. When you got them, just shout them out. Go, Emmett.
C to D is 4.12.
A to D is 5.39. B to C is 5.39.
Looking good so far. Michael?
AB is 4.1.
Beautiful. So Mary, what does that tell us? Because? Perfect. Well done. Okay, there's one method. Okay. We showed that the opposite sides are congruent, therefore it's a parallelogram. Well done, Mary. Changing colors here to blue. Jack, what do you want to do now? You got 5 to choose from. Hold on. He doesn't get off the hook that easy. What do you want? We got them in your notes. Look one up. Saying I don't know doesn't get you off the hook. Should never be proud of your lack of knowledge. Unless they ask you who killed that guy.
Oh.
Hold on. Beautiful, consecutive angles. There's one small problem. That would work if we had if this were a trig class, we could do that because we could calculate the measure of those angles. We're not ready for that yet. But yes, that would work. Molly, what were you going to say? Midpoint of the diagonals. Is that what you were going to say too?
No.
Good, we'll come back to you. Midpoint of the diagonals. I thought I changed colors here. Rebecca, could you find the midpoint of AC for me, please?
Yeah.
And Will, could you find the midpoint of BD for me? What is going on here? Blue. Okay, there we go. You got it?
Yeah, BD is 4.2.
Becca?
Give me a second. It's 4.2.
Beautiful. Therefore, Molly, what do you got for me? It's a parallelogram because they share a common midpoint, which means the diagonals bisect each other. Back to you, Ben. What do you have for me?
Find the slope of all the line segments.
Awesome. Let's see. We want the slope of BC. We want the slope of AD. We want the slope of AB. And we want the slope of CD. Okay, let's see. Grace, could you do BC, please? And Paul, could you do AD, please? And Michael, could you do AB? And Michelle, could you do CD, please?
Oh wait, I have a story.
Oh, excellent. Ben's got a story, everybody. Can we finish this first? Okay, good. Does it involve the splits?
Not really.
Me doing the splits reminded you of the story?
Yeah, kind of.
That's kind of scary.
Well, like it reminded me of the time.
I understand. What do you got?
4.
For what?
AB.
AB is 4. Who had CD?
I think I did. I thought. Wait, is it supposed to be? Isn't it supposed to be a point?
No, it's a slope.
No, slope.
Oh.
We're doing slope. We'll come back to her. Who had BC and AD? Grace, what do you got?
2/5.
For which one?
BC.
BC, 2/5?
2/5.
2/5. And seeing as we already know it's a parallelogram, we know what we're going to get, but we'll wait for you to finish the calculation because we want to be courteous that way. What'd you get, Michelle?
I got 4.
Yeah, I bet you did. Okay, good. What else? So we did opposite sides congruent, opposite sides parallel. We said that we can't do the consecutive angles. We also can't do the opposite angles. And then the new one that we have would be a pair of sides congruent and parallel, which we did in the process of doing the others. Pregunta?
Yeah, isn't the slope of CD -4?
I don't know.
Yeah.
I left it up to them. Should be negative.
Yeah, you get -4
Over 1. Yeah. Rise over run.
I did -1 minus 3 instead of 3 minus
Well, that kind of backfired on you, didn't it, Michelle? You trust them. All right, story, Ben.
Oh, okay. So I was sledding with a couple of my buddies at Mellis, and since it wasn't
Over break?
really, yeah, over break.
Okay.
And it wasn't really snow; it was like a sheet of ice kind
Right,
of.
yeah, because of the nasty weather.
Yeah.
Okay.
But there's like this one like huge puddle, right? So it was like the last run because we're getting picked up, and then I went down, but I could stop before, but my friend pushed me. Like he didn't really push me, but he kind of like nudged me, and then I couldn't stop, and then like I kind of stood up off my sled, but I still had the momentum. And I tripped and I fell into this huge pile of water.
You were standing on the sled while it's going down
No,
the hill?
no, no. I was like, I was on the
You would come to a
sled.
stop.
No, and then, so I was going down.
Okay, you're going down the hill.
And
You're
then
on. You're
it-
seated. You're seated on a sled.
Yeah,
Gotcha. Okay.
and I'm trying to stop.
Right. Trying to stop.
But then, so I kind of like stand up, but I'm still like running, kind of.
Oh, I gotcha. So you're off the sled now.
Yeah.
Yeah.
Yeah,
Trying to, okay. So now the
yeah.
sled's gone and you're running way out of control down the
Yeah.
hill. Yeah.
Yeah, and then I tripped and fell in a bunch of water.
Did you belly flop into the water or face
No,
plant?
I
or?
like turned.
So then you got picked up and had to get in the car
Yeah, all
with
of it.
puddle juice all over you.
And the splits, doing the splits reminded me of that because I tore my pants while
You split your pants, or you just like
Yeah.
tore a hole in
No,
the
I
knees? You
split
split
them.
them. Oh, that's great. That's awesome. That's a good one. So you're wet, you're cold, and your pants are split. It's not a good way to go through life, but
No.
that's a good one. Anybody else have a good story? Okay. Whoops. Okay, we're all done.
Wow.
Fast fact about squirrels. In
Oh, it's so long.
case you're wondering.
I hate squirrels too. There was a squirrel in my house.
I would have left the house.
Oh,
Do you have a pet squirrel or
No, it's painted inside.
did you invite it in? How did they get in? Did it ring the doorbell?
So you can have garages and I open the door.
And decided to come in? Ran like a crazy thing all over the house? Good time.